All right, so last time we really dug into all those different ideas about like what well-being actually is. And today we're going to shift gears a little bit. We're going to be looking at how well-being is actually structured and like whether we can really measure it, which honestly this stuff it's super important for getting a handle on a lot of ethical and economic theories,
Mhm.
that sort of rely on these concepts.
Yeah, absolutely. I mean, going beyond that, like general feeling of, like feeling good to something more structured, that's what really lets us, analyze and then compare well-being. And we need that to be able to
Yeah.
apply these frameworks or the frameworks that are trying to improve, overall welfare and all that.
So really the big question we're diving into today is whether well-being like has this ordinal structure or a cardinal structure. I know it might sound a bit technical at first, but trust me, it's got some pretty big implications for, like real life stuff. Like imagine Anne and Bob are trying to figure out where to go on vacation. Do they go to Canada or do they hit up Thailand? Let's just say, for the sake of argument, we've got some numbers that show how much they'd enjoy each place, right? So Anne, she gets like an 8 for Canada and a 4 for Thailand. Bob, on the other hand, he's got a 4 for Canada and a 5 for Thailand.
Right. Yeah. And as soon as you see those numbers, you kind of start wondering, okay, so is Canada like overall the better vacation spot compared to Thailand? I mean, you might just look at it and think, oh, we'll just add up the numbers, right? 12 for Canada, 9 for Thailand. Easy.
But hold on a sec. Doing that kind of assumes those numbers aren't just rankings. It assumes they represent like actual units of well-being, like units that you can actually compare and add up between different people, right? That's a pretty big assumption to make about the very structure of well-being, don't you think?
Yeah, totally. You hit the nail on the head. It brings us right to the heart of what we're talking about, ordinal and cardinal representations. These are like the two fundamental ways we can try to grasp how well-being might be structured. So we're going to start by looking at ordinal representations and what they mean, and then we'll shift over to cardinal ones. And then finally, we'll touch on how we might, actually try to measure this whole individual well-being thing using something called the VNM utility function. And then our next deep dive will really tackle that whole, can of worms about comparing well-being between different people.
Okay, so let's start with ordinal representations. Like, what does it actually mean for well-being to have an ordinal structure?
So basically, an ordinal representation, it lets us rank stuff. Like say whether one thing is better or worse, or maybe just as good as another thing. The catch is it doesn't say anything about how MUCH better one option is. It's all about like just the order of things, the relative order.
Right, that makes sense. It's like ranking your favorite books, right? You could say, book A is my absolute favorite, then book B, and then book C. That's an ordinal ranking right there.
Yeah.
But it doesn't necessarily mean that, book A is giving you like 3 times the enjoyment of book C or anything like that.
Yeah.
You're not really quantifying how much more you like one over the other.
Yeah, you got it. That's a great example. And, think about it. It's like temperature scales,
Mm.
right? Like Fahrenheit and Celsius. The sun, it's got one real temperature, right?
Yeah, yeah.
But we can use totally different numbers on each scale to represent that same temperature. It's the same idea with Anne's well-being in different situations. We're trying to represent this one underlying reality.
So just like we use different temperature scales to, talk about the same level of heat, we can use different I guess you could say utility functions to represent how Anne feels about, different choices.
Right. A utility function is just a way of giving each option a number, like a number that represents how good that option is for Anne. So let's say Anne is deciding what to drink: coffee, tea, juice, milk. We'll call them C, T, J, M. Just keep it simple. And one utility function, we can call it UA. It might give these values, right? Coffee gets a 4, tea gets a 2, juice gets a 1, and milk gets a big fat 0.
Got it. So those numbers, they show how much Anne likes each drink according to that specific utility function. But you were saying that there could be a bunch of different like valid scales that could represent her well-being, right? So what makes one particular utility function, like a correct ordinal representation of Anne's well-being?
Well, at the very least, a good utility function, it has to accurately reflect what Anne actually prefers, right?
Mhm.
So if she likes coffee more than tea, then the utility number for coffee has got to be higher than the number for tea. And that has to hold true for all her choices.
Yeah.
So here's the formal definition. A utility function, we'll call it EO. It's an ordinal representation of Anne's well-being. If and only if UX is greater than or equal to UY, only when X is at least as good for Anne as Y. In plain English, the numbers that the utility function spits out, they've got to line up with how Anne actually feels about stuff.
Okay, so if Anne's preference goes like Coffee is better than tea, better than juice, better than milk, which we could write like C, the greater than symbol A than T, greater than symbol A than J, greater than symbol A, and then finally M, right? So our utility function from before, UA, with its 4, 2, 1, 0 for coffee, tea, juice, milk, that works. But he said other utility functions could work too, right? To represent the same order.
Absolutely. We could have 12, 6, 3, 0, for example. That works perfectly fine for the same preference order. Or even 16, 4, 1, 0, or even approximately 2, 1.4, 1, 1, and 0. They all get the job done. They show that Anne likes coffee best, then tea, then juice, and then milk. And they all capture that same underlying ranking. Like, you can't tell just by looking at the numbers whether she, really hates milk or just kind of prefers juice.
So the specific ratios between these numbers, they don't actually tell us anything important in an ordinal representation.
Exactly. It's all about strictly increasing transformations.
Yeah.
So let's say we start with the utility function, right, which we already know is ordinal, and then we apply a function to it. We'll call it f. So now we have this new utility function, vx equals f dx ex. And the key here is that this function f, it always has to increase when its input increases. It's called a strictly increasing function. And if that's true, then this new function, we have e, it's also going to be a valid ordinal representation of the same preferences.
So as long as ACK is ordinal, we can do any transformation to it as long as it's a strictly increasing one, and we'll still have a valid ordinal representation.
Okay, so how does all this connect to ordinal well-being statements?
Okay, so an ordinal well-being statement, it's a statement about how Anne feels about things. But the important part is it has to stay true no matter what ordinal representation we use. It can't depend on the specific numbers. It has to be about the direction of her preferences, whether she thinks one thing is better, worse, or the same as something else. And anything that involves like how much CH better one thing is, that's usually not ordinal.
Okay, let's play around with some examples then. Let's go back to our UA function with 4 for coffee, 2 for tea, 1 for juice, and 0 for milk. What about this statement? The well-being that Anne gets from tea is greater than from coffee. Well, if we just go by our UA function, that statement is false, right? 2 is definitely not greater than 4. And it's a false ordinal statement because no matter what strictly increasing transformation we do, Anne is always going to prefer coffee over tea. That order isn't going to change.
Okay, how about this one? Anne's well-being from coffee is twice her well-being from tea. So with UA, that's definitely true. 4 is twice 2. But is that an ordinal statement?
Nope, not ordinal. Let's say we use UA squared instead. So now we've got 16, 4, 1, 0. And suddenly, Anne's well-being from coffee, 16, is 4 times her well-being from tea, 4. So the truth of that statement totally changed just because we changed the utility function. And that means it's not ordinal. Specific ratios, they just don't hold up when we're talking about ordinal stuff.
All right, how about this? The difference in Anne's well-being between coffee and tea is larger than between juice and milk. So with UA, we have 4 minus 2, which is 2, and 1 minus 0, which is 1. So that's true.
But let's try using the square root of UA. That gives us approximately 2, 1.4110. Now, the difference between coffee and tea is about 0.59, and the difference between juice and milk is 1. So the statement becomes false, and that means it's not an ordinal statement.
Okay, one last one. How about Anne's well-being from tea is greater than from milk? With UA, that's definitely true. 2 is bigger than 0, so would that be ordinal?
Yes, that would be an ordinal statement. It's true with UA, and it'll stay true no matter what strictly increasing transformation we use, because the order is always going to stay the same.
Okay, so a good ordinal representation, it captures all those true ordinal statements about preferences, right? But now let's move on to cardinal representations of statements. This is where we go beyond just ranking, right?
Exactly. With cardinal statements, we're not just talking about order. We're talking about the actual magnitude of well-being, the size of the difference in well-being between different options, that kind of thing.
You mentioned diminishing marginal well-being before, or DMW. You said that's a non-ordinal statement. Could you maybe explain that one again?
Sure. So imagine we're thinking about Anne's well-being, but this time it's tied to how much money she has. DMW, it basically says that if you give Anne €1 more, the increase in her well-being is going to be smaller if she's already rich compared to if she's broke.
Right.
Like that €1 means more to her when she's got less. It's about the relative impact of that extra euro.
Okay, so it's not just about whether her well-being goes up, but about how much it goes up.
Exactly. And to dig into that, we need to talk about positive linear transformations. So a utility function, V, it's considered a positive linear transformation of another utility function, U, if Vx equals alpha times Ux plus beta. And here, alpha, that has to be a positive number, and beta, that can be any number at all. And these transformations, they're definitely strictly increasing, but not all strictly increasing transformations are positive linear. Like the square root function, that's not a positive linear transformation.
So with these transformations, you're basically just scaling and shifting those original utility values, right? So how does that connect to cardinal statements?
A cardinal well-being statement, it's a statement that stays true even if we apply any positive linear transformation to the utility function. It's about the statement itself, not about the specific numbers we use to represent well-being.
Okay, let's go back to that statement from before. Anne's well-being from coffee is twice her well-being from tea. We already know that's not an ordinal statement. Is it a cardinal statement, though?
Well, let's test it out. If we use a positive linear transformation, like 2 times UA plus 1, our original 4, 2, 1, 0, that becomes 9, 5, 3, 1. And 9 is definitely not twice 5. The statement is still false, so it looks like it's not a cardinal statement either.
Right, so it's not preserved under positive linear transformations, but a statement about DMW, like we saw before with those specific numbers, that can be preserved under these transformations, right? So that makes it a cardinal statement in that context.
Exactly. And you know what? The whole temperature analogy with Celsius and Fahrenheit, it actually helps illustrate this idea of cardinal statements.
Because those two scales are basically just positive linear transformations of each other, right?
Right. And if you think about it, statements about, the difference in temperature or maybe like the ratio of those differences, they stay consistent no matter which scale you use.
Mm.
That makes them cardinal statements about temperature. But if you had a statement about like the specific ratio of the absolute temperatures, that wouldn't hold up because those ratios would change depending on which scale you're using.
Okay, so cardinal statements about well-being, they let us compare the size of the changes in well-being. And these comparisons actually mean something, even if we're using different cardinal scales, as long as they're valid, of course. And you also mentioned before that any ordinal statement is automatically a cardinal statement. Why is that?
Well, it's because positive linear transformations, they're just a specific type of strictly increasing transformation. So if a statement holds true for every single strictly increasing transformation, which is what defines an ordinal statement, then it definitely has to hold true for that smaller group of positive linear transformations, which is what defines a cardinal statement.
Got it. So there's a clear hierarchy there. Okay, but now we're getting to the real nitty-gritty. We want to be able to actually measure well-being, and we want to do it in a cardinal way. How do we even go about doing that?
Okay, so that's where the von Neumann-Morgenstern VNM utility function comes into play. Remember how we talked about measuring temperature? We need those fixed points, right? Like the freezing and boiling points of water. And then we need a property that changes reliably, like, how much mercury expands. So VNM, they came up with this method that's based on preferences under uncertainty. And the idea is to use that to try and establish a cardinal scale for well-being.
So that's where you bring in stuff like lotteries and choices with probabilities of getting different outcomes, right?
Exactly. So let's imagine that Anne, she prefers coffee, which is her best outcome, to tea, then juice, then milk, which is her least favorite. So the VNM method, it starts by giving coffee the best outcome, a utility of 1, and milk, the worst outcome, gets a utility of 0. And then for the other outcomes, tea and juice, you got to figure out the probability, we'll call it P, where Anne would be indifferent between getting, let's say, juice for sure versus taking a gamble. A gamble where she has a P chance of getting coffee and a 1P chance of getting milk. So that probability P, that becomes the utility of juice.
So if Anne doesn't care whether she gets juice for sure or takes a gamble with a 30% chance of coffee and a 70% chance of milk, then the VNM utility of juice would be 0.3.
Exactly. And there's a theorem, it's called the VNM expected utility representation theorem, or EUR theorem for short.
Yeah.
And it basically says that if how Anne feels about different lotteries follows certain rules, these are called axioms, things like completeness, transitivity, monotonicity, continuity, and independence. If her preferences follow those rules, then this utility function we get, UEREAA, that will actually represent her preferences in a specific way. Basically, she prefers one lottery over another if and only if the expected utility of the first one is higher. And any other expectational utility function that also represents her preferences, it's going to be a positive linear transformation of UA.
And because it's unique up to a positive linear transformation, like you can't just multiply it by any random number and still have it represent her preferences accurately. That's why some people see it as a potential cardinal measure, right?
That's the general idea. But the really important part, the thing that people debate, is whether how Anne actually feels about those lotteries really follows those VNM axioms. And then there's also the question of whether her preferences can only be represented by those expectational utility functions, or if there are other ways to represent them. There's a lot of back and forth about all this.
So it seems like V&M, it's a really useful tool for, modeling decisions when there's uncertainty. But whether we can directly interpret it as like a definitive measure of well-being for ethical theories, well, that's still up in the air.
Yeah, that's a good way to put it. And, for utilitarianism, for that to really work how it's supposed to, we need more than just a cardinal measure of well-being for each person. We also need a way to compare the well-being of different people. Is Anne's 8 for Canada really comparable to Bob's 5 for Thailand? And that's actually what we're going to be tackling in our next deep dive.
All right, so let's do a quick recap. We've covered ordinal representations, which, they let us rank different options. And then we moved on to cardinal representations, which give us more info about the actual differences in well-being. We saw that ordinal statements, they hold up under strictly increasing transformations, while cardinal statements, they hold up under positive linear transformations. And then lastly, we talked about the V&M utility function as a potential way to get a cardinal measure of well-being for an individual based on how they feel about different gambles. But we also highlighted that there's still a lot of debate about how to interpret all of that.
And for those of you who want a really thorough rundown of all these concepts, plus some practice tests to really solidify your understanding, head over to gradeguru.nl. It's all right there waiting for you.
And now for a little something to ponder. When you're facing a decision where things are uncertain, do you think your choices actually reveal a cardinally measurable sense of your own well-being? Or are they just showing the order of what you prefer? It's something to think about, right?
And join us next time on the deep dive, where we'll be diving headfirst into all the complexities of comparing well being between different people. It's going to be a wild ride.